A block of mass 6 kilograms is at rest on a rough plane inclined at 30 degrees to the horizontal. The coefficient of friction between the block and the plane is 0.4. Find the least tension in a light, inextensible rope required to pull the block along the plane if the force is A, parallel to the plane, B, at an angle of 45 degrees to the plane. Okay, what's very, very important in this type of question, obviously, is drawing a clear, large diagram with the forces acting on the block. So for part A, your diagram should look like this. You've got a block, you've got a plane inclined at 30 degrees, you've got a tension action in that direction, friction acting in that direction, and remember friction is equal to mu r. You've got a weight acting downwards of 6g newtons, and you've got a reaction of the block with the plane being r newtons. We introduce I and j, I being parallel to the plane and j being perpendicular to the plane. What we need to do is when a sliding is just about to occur, the friction is said to be limiting, and that F will be equal to mu r. Okay, so if we resolve along this way in the I direction, so we've got a T, the tension in the rope, and then going in the opposite direction, we've got the weight, but we've got this component here of the weight acting against the tension. So this is going to be 6g sine of 30. Remember, this angle here is always the same as this angle here. And we've also got the friction acting against the direction of where it's trying to move. Don't forget, it's not actually moving, but so the friction will be acting in that direction. So it's going to be minus mu r. Now this is going to be equal to 0, so it's in equilibrium because it's just on the point of moving. We'll call that equation 1. Now equation 2 we will resolve in the j direction, i.e. perpendicular to the slope. So we've got r newtons acting upwards, and then in the opposite direction we've got this force here, this component here of the weight, which is 6g cos 30, 6g cos 30, and again there's no movement in that direction, so that'll be equal to 0. So we've got our two equations, 1 and 2. We now just need to resolve these in order to find the tension that's required. So just writing them out again, and this is how you resolve them. So from 2, so from this one here, you say that r is equal to 6g cos 30, and then you substitute into 1, but also you use the fact that mu is 0.4 given in the question, the coefficient of friction. So we're going to have t minus 6g sine 30 minus my mu, which is 0.4, times my r, which is 6g cos 30, and that's equal to 0. So we now make t the subject. So therefore the least tension required is given by t is equal to plus 6 sine 30. Now minus 0.4 times 6 is 2.4, so we're just going to record, and then it'll become plus when it moves over to this side, so it'll be plus 2.4 g cos 30. And then on my calculator, I'll work that out, make sure my calculator is in degree mode, and take g to be 9.8 meters per second squared. Let's just write that down. Acceleration to gravity, and then that will give me 49.796 newtons, and we round it off to three significant figures, so it gives me a force of 49.8 newtons. So with a force of 49.8 newtons, the block will just start to move. Now the interesting thing is if we now pull at an angle of 45 degrees like in part B, but the procedure is just is the same. So if we resolve in the I direction, i.e. along the slope, now we've got to remember that the bit along the slope component of this force here is going to be this one here, which is going to be t cos 45. So t cos 45, and now the weight, this component of the weight is acting against that, so it'll be 6 sine of 30. So you're going to be pretty good at your trig here, minus the friction, minus mu r, and again is equal to 0 because just on the point of moving. And now if we resolve perpendicular to the slope, i.e. in the j direction, we're going to have, now we've got this component here, extra component here, this will be t sine 45. So t sine 45 plus the reaction of the block with the slope minus the weight component acting in the opposite direction of 6g cos 30, and that's equal to 0. So we've got our two equations, we now need to solve them. So from 2, similar idea, we make r the subject. I know we've got another variable in it with t, but we'll still make r the subject. So r will be 6g cos 30 minus t sine 45. And again, we just substitute that into equation 1 and making mu equal to 0.4. We just need to be a bit careful here. So t cos 45 minus 6 sine 30 is what we had up here, minus 0.4 times all of this, which is going to be 6g cos 30 minus t sine 45. Now, if collect all the terms with t on one side and expand the bracket, so we've got, that's also equal to 0, don't forget. So it's t cos 45. Now, minus times a minus makes a plus, so we're going to have plus 0.4 t sine 45 from doing that multiplication here, and then we've got over on minus 6g sine 30, and then minus 2.4 g 2.4 g cos 30 degrees. Don't forget the g. Right, so we have a common factor here of t, so that can come out. So we've got t brackets cos 45 plus 0.4 sine 45. And then that will be equal to, if we take that over, we're going to get 6g sine 30 plus 2.4 g cos 30. And then to find t, we'll do 6g sine 30 plus 2.4 g cos 30. And then divide it by cos 45 plus 0.4 sine 45 by taking this down here. Now, using the fraction button on our calculator, taking g to be 9.8 meters per second squared, you're going to get a tension being equal to 50.274 newtons. So the least tension required is going to be 50.3 newtons. Okay, so this has been a video to show you how to calculate limiting friction when a block is moving up a slope. I hope you've understood, and I thank you very much for watching.